We've already looked at solving basic exponential equations where we can get the bases to be equal. Today we're looking at the little bit more complicated ones where it's impossible to equate the bases. When you have an exponential function, so in other words, when there is a variable in the exponent, there are several steps to follow. The first thing you want to do is take the log or the ln of both sides. It really doesn't matter if you take the log or the ln. I typically only take the ln if there's an e involved, because you'll see here shortly that that helps one piece disappear. Once you take the log or ln, you're going to move the exponents out front. And finally, you're going to get x alone to solve for x. Let's do a couple of examples. Let's begin here with number 1. We've got 3 to the 2 minus 5x equals 11. I'm going to take the log of both sides. That means this entire piece can move out. Be careful to put that entire piece in parentheses, because you'll see that that entire thing is multiplied by log 3, and that equals log 11. Well, now I can distribute that log 3 to everything, or I can divide first. I'm going to divide first because notice now this leaves me with 2 minus 5x equals log 11 over log 3. And I can subtract 2 from both sides, leaving me with negative 5x equals log 11 over log 3 minus 2. And last but not least, I can divide the whole thing by negative 5. And so my final answer is x equals the log of 11 divided by the log of 3 minus 2 all over negative 5. You may see that rewritten a little more succinctly as x equals log 11 over log 3 over negative 5 plus 2/5, which is the same thing. In the second example, because an e is involved, I'm going to choose to take the ln of both sides. However, the same steps apply in terms of I can pull my exponents out front. So this now becomes 3x minus 10 ln of e equals 2x plus 1 ln of 124. The nice part about this one is if you go over here and calculate the ln of e is simply 1. So in a sense, this piece can just disappear, leaving me with 3x minus 10 equals, I'm going to choose to multiply everything out here. So I have ln of 124. I'm not sure why I keep writing 125. Sorry about that. Times 2x plus ln of 124 when I distribute to both pieces. I want to get my x's together. So I'm going to move this entire thing over. Which leaves me with 3x minus 2x ln of 124 minus 10 equals ln of 124. And then I can add 10 to both sides, which gives me 3x minus 2x ln of 124 equals ln of 124 plus 10. I still want to get my x's by themselves. So to do that, I can factor x out, which leaves me with 3 minus 2 ln of 124 equals ln of 124 plus 10. And now I can divide by this entire piece here. X equals ln of 124 plus 10 over 3 minus 2 ln of 124. This would be the exact answer, and then I can plug it in to get the rounded answer. Let's do one more example of an exponential. Here we've got 8x to the x minus 4 equals 1,299. You could take the log or the ln of both sides. I'm going to take the log. This piece comes out front. I could distribute. I'm going to choose instead to divide both sides by the log of 8. And I have x minus 4 equals log of 1299 over log of 8. And then I can simply add 4 to both sides, and x equals log of 1299 over log of 8 plus 4. Just as a side note on the very first problem we did that was similar to that, if you wish to, you can rewrite this and bring this piece together so that it can be more simply written as log of 11 over negative 5 log of 3 plus 2/5. That's the same thing and can make it a little simpler.